Hi there. In our last video we looked at the robotic arms and we sort of created some rough geometry and discussed the way that they would work. In this video I'd like to focus on the blades a little bit before resuming progress on the robotic arms' third and final component, which is the tool that potentially holds the blade. So to edit these blades, let's jump right in and let's get this reference object. Right now it's a null object. It contains geometry. And I believe it's over on this side. So when we look at these blades, one thing keeps coming to mind. How is the machine going to be able to easily swap them in and out? And the more I think about this, is the more that the mechanism I'm about to create comes to mind. So let's see. If I were to move this lower blade, yes, it moves both. So let's move it a little bit away from that piece of plastic. Now the blade is currently made up of two parts. The actual polygonal piece of this blade, and then a base. The base, I think, is what's really important. Let's focus on that. So right now it's still a cube, a primitive cube, but I'm going to need to edit the polygons of it, so let's make it editable. And I'm going to use a really simple modeling technique to punch a hole through it. This is one of those instances where it's easier to not use a boolean because the geometry you're working with is so simple that it doesn't really require it. If I select the faces on either side, and then I do an extrude inner command, we can get a nice inner set of faces on both sides. I'm going to hide most everything else. Let's hide the arms, LiDAR, let's see, the actual Razorback, and let's make the blades visible. So, symmetry hidden, LiDAR, flare proxy, cube. I want all that stuff to be out of our way. So we're just working on these blades now. Now we have this geometry sort of roughed out. The next thing we need to do is actually punch the hole through it. And we can do that with the bridge technique. This is actually one of the first tricks I learned in Cinema 4D, where if you have geometry in this configuration that you see right here, if you use the bridge tool, you can actually just bridge polygons right through the object. So it looks like that. And the next thing that we'll need to do is move this face away from the upper edge of this bracket, because the blade is going to need something more substantial to be mounted into. I think that should be enough. This gives us a good idea of how our blade is going to sit. So we can take the blade and we can move the blade up into the area that it belongs. Now these blades are starting to look a little bit more like they are modular. I know earlier we spoke about a disposable razor being the inspiration. And the next thing I'll do is use the ring selection. So I believe it's UB, correct? Select those edges and these edges. And I'm actually going to melt them, because we don't need them right now, but we will recreate them in a second. Still using the ring selection, if we select these edges on the inside, we can do a bevel. I'll do subdivision of 1 with a type of convex. And that gives us a nice rounded pill shape. And that's actually the shape I'm going for. So we see that because we removed the edges that were on the faces, Cinema 4D is dynamically triangulating these n-gons. It's also created n-gons for the beveled shape right here. This is a 6-sided polygon. So what we can do is use the loop tool and select everything on the inside and then we can remove the n-gons. That gives us more traditional geometry to work with. N-gons are absolutely fantastic. They're great. They're great for during modeling, but once you're done modeling, it's a good practice to get rid of them. Now we can select the two edges at the base of this bracket, and we can do the same exact bevel to them. If we wanted to be really particular about it, we can just hit apply again, or new transform, and it would apply the exact same radius we just used. But when I think about it, we may actually want to use a different radius, so we can say apply, and then we can just tweak the radius as we see fit. Now, after a certain point, you see Cinema 4D figure to itself, the geometry looks really good there. I'm going to retriangulate it. That's some things to watch out for, because the physical appearance, the difference between the physical appearance of this and this is very minor, but the way Cinema 4D decides to triangulate can save you a few minutes of modeling time. So once we have this, we can say, okay, does it need to be tweaked? Does the shape of it look okay? And to be honest, these ends are a little bit too blunt for my liking. I'd prefer if they were disproportionately sharp, but still rounded. So something like that looks a little bit more industrial. It looks more like it's born from function instead of form, which is what I'm going for in this particular component. So I can remove these n-gons now. Now because Cinema 4D didn't see things our way, we have to manually retriangulate these, and this is probably a good time to do it. So we can select the line mode of our knife tool, and we can just start guiding Cinema 4D, and as we create the primary lines, it sort of jumps in and says, oh, okay, obviously he wants me to triangulate it like this, which is correct. It's exactly how I wanted it to divide my geometry. So I can then remove those n-gons, and we kind of get the picture until we get up here, and we have a couple of choices. We can either round these edges up here, which I'd rather not do right now, or we can add extra geometry, which I'm actually okay with. So the way we do that is we select these two polygons, and then we use the knife tool in loop mode. That'll allow us to select a loop of edges like this. So it turns out I didn't actually need to select the two polygons, but the reason I selected them was that sometimes your selection goes kind of crazy, like that, but it actually does intersect selected polygons at the right area. In that case, you just say restrict to selection and make your cut. But in this case, our geometry is still clean enough that I don't need that. So the first thing I'd need is, actually, you know what? I do need that, because it's going to try to cut this very strangely. So I'm going to say restrict to selection. First place I'm going to cut is right there. And then I'm going to make another cut right there. And that gives us enough geometry so that this quadrangulates perfectly. Now, it is kind of bad practice to have three faces here that are exactly aligned. So just to heed my 3D teacher's warning and make this look a little bit more interesting, I can make it bulge a little bit and just give these extra bits of geometry some purpose. It's completely unnecessary, but it's just one of those tics that I have. So we can remove those n-gons, and now we have eyelets in our blades, and they look intentional. It looks like the hilt of a sword, but designed for a machine to interface with. Now, I kept thinking to myself, how will the machine actually grip these blades? How is it going to hold on to them firmly while easily being able to discard? And the only thing I could think of was actually a pair of pins. So if this machine has been thrashing something with these blades, and then it needs to replace them, what we're going to be dealing with is potentially something that's a little mangled and damaged. So what I was thinking is, I'm just positioning this cylinder. I'm just going to zero out its position and rotation. And what I was thinking is a pair of pins. So if I were to orient this cylinder on the x-axis, Give it like a really low number of segments, like 8. We're just experimenting at the moment. And if we had a pair of pins like this, I think it would do really well to hold the blade in place, as long as once the pins were sort of, let's see, inserted into the blade, they were rotated like this, potentially by the arm that sort of grips them. So they were rotated outwards, being held by some sort of a pressure plate on the other side. See, that way I'm thinking that even if this area has been abused and mangled and damaged, if the machine were to remove the rotation on these pins that's holding the blade in place, it may have the ability to simply fall off. So it may not be a sound engineering approach to this, but it's what I'm going to use because it makes sense to me. Now, as I've said before, just because it makes sense to me doesn't mean it actually makes sense, but I'm going to go with it. For some reason, these... Oh, okay, I see. It's because the cylinder is not a child of the base, which is why its rotation is off by 6.567 degrees. So if I make it a child of the base, it doesn't have that offset issue anymore. And it would be perfectly centered. Now I'm going to need 2 of these pins, so I'm going to rename this pin, and then I'm going to create an instance of it. I'm not being my stubborn self where I'm grouping it into a null first, because I'm not really sure what's going to happen with these. These are just a couple of proxy objects for right now. So if that's how these are going to be locked in, and we're assuming that the machine is going to need to reach them, we need to figure out which side is it going to reach these from. Now, before I started recording, I did a little calculation. And yeah, note, these pins would actually be connected to the arm. I just have them in the blade right now for reference. So I did a little bit of experimentation here before starting my recording, and it looks like if these arms were to rotate in a manner similar to what I'm doing right now, you could envision the machine reaching down and grabbing one. So the way this would work is we would add a another degree of freedom. So right now the arm can do this, and it can move its arms, but what it can't do just yet, but what I may change, is the arm base doesn't have any rotation like this. I was looking at it, and if the arms were pivoted out slightly, and the arm base could actually rotate slightly, you can see that this arm now has the ability to potentially reach any of these blades. So as long as the large arm can rotate downwards and the small arm can adjust, and then whatever holds this blade in place can potentially line it up with the next blade that needs to be loaded. Now, using this technique, the blades would mount themselves from the inside. So that answers that question for us. Now, it could just as well mount from the outside, however. So maybe it doesn't answer the question. Either way, we need to create a plate that holds this blade in place. So let's start there. Let's pivot these arms out 90 degrees just so they're out of the way. And rotate the blade instance here at the end so it's a little bit more streamlined. So we have this pair of cylinders. They're actually a member of the main instance on the base of this arm, way over on the other side here. And we're going to need a plate to go along with them. Now this plate would presumably have some sort of a mechanism inside of it that would allow it to rotate the pins very slightly so that they lock into place, but we're going to leave that up to the imagination. For our purposes, this is simply going to be a plate that sits around the area it needs to and sort of conveniently intersects with these pins. So let's think. If we go from the outside, it means that looks like the inside is kind of cramped. We're gonna have to go from the outside either way. So if this is our plate, we can now make our pins a child of that plate. And we can then move this plate onto the robotic arm. So the small arm will probably have another child that would represent the tool at the end, and that would contain the plate. And right now the small arm has a cylinder and a plate. The cylinder is the motor up here. Whoa. Sometimes running the screen recording software, the mouse movement freaks out. Okay, so we have this cylinder up here, and we have a plate down there that I just moved. And we have the blade instance. So I'm probably going to have to transfer this plate to the blade. And then we can position it so that it's correct. And that's the idea. Where we used to have the blade directly rotating, we're going to have the plate directly rotating. So to do that, I think we should group the blade just by itself. That's going to create a null object at the same location. Ungroup it, Shift G, and then place the plate as a child of that null. So now we have a null object that we can move like the plate that holds this arm. This blade, rather. I think we can then safely say that this blade instance, the equipped blade, should be a child of the plate, just for now. Or rather, a child of the null that the plate is also a child of. So these two objects will now move together. Brilliant. And because this is going to be coming off of some sort of a pivot, and we agreed that, well, no, looks like we have the space. What I'm thinking is that when these are folded up, like that, will we have the space inboard? And it looks like yes, we will definitely have the space inboard. No need to put them outboard. However, inboard might get bulky when reaching for a new blade, so let's put it outboard. We can always change these things later. So this is the pivot point for the arm at the end, and we're going to move it a little bit like that. Now this is the part that we really haven't figured out. What does the final stage of this arm look like? What does the tool at the end of it look like? So we have, well, there's a lot of geometry here. Okay. So we have potential to put a rotation point right there. Let's see what this looks like. So right now, this is the center of everything. We can probably move this center point a little bit offset just to keep it interesting. That way, when you swing the arm around, it's not completely centered. I'm sure there's pros and cons of that. And then we would need to bring the small arm out to meet that. So the small arm would get a little bit longer, and using our same edge smoothing technique, we can let's see, bevel these edges a little bit. And there would be some sort of a pivot right here. What kind of a pivot? I'm not really sure of. It could even be sort of musculature based, like a pneumatic ram. The movements at the end of the blade would be presumably really quick. So there's a lot of different ways that that can go. For now, this will be fine. So if we were to do some more renaming, let's say that, let's get everything back to 0. So the pivot is zeroed. We have the geometry here for the pivot. And then we have our arm base. We have the geometry for the arm base. And then we have the cylinder. And then we have a null object that the large arm rotates on. Let's see. And then, then we have the large arm. So if we zero the large arm, we can now rotate using the null. I think I prefer that. And then we have this null, which represents the small arm. So if we zero the small arm's pitch, we can now rotate using the null that is the small arm. Good. Then we have the small arm's geometry. And not as a child of the small arm's geometry, but as a sibling of the small arm's geometry, we have this final null, which is the actual blade pivot. And right now, we're not actually sure what that does. All we know is where it is, and we know that we're not done with it. Just to create some proxy geometry, I like creating proxy geometry for this sort of stuff. Let's create a cylinder. Just need a few segments. 12 should do it. Along the x-axis. And this is going to help us visualize where the rotation point of this arm is. The first thing that'll help me do is reposition the small arm's endpoint so that it makes a little bit more sense. Right there. And the cylinder just needs to be a very thin one. Again, it's just representing that there's something there. We don't really know what it is yet. Now if we place this newly created cylinder as a child of the so this is arm base, large arm, small arm. Okay, so this is large arm null, small arm null, end arm null. We can place it as a child of end arm null. It replicates it over to the other side, and if we rotate the end arm, it pivots as well, just as a reminder that that's why it's there. Now let's collapse the arms again. Let's try putting the large arm part forward and then bringing the small arm part down and then folding the end of the arms. So that gives us another interesting look for the arms stowed away. The nice part about this is they're poised to strike as well. So I think that'll do it for now. I'm not sure what we're going to cover in the next video, but I'll see you when we get there.